When given a graph of a quadratic function, one of the first things you want to do is identify the key features. The vertex of this graph is located at 2, -3. The next thing you want to notice is any vertical stretch. On this graph, if you go to the right 1 unit, the graph is up a half of a unit. That means that the vertical stretch is actually half as tall as it would be for y equals x squared. We can take this information and write it in vertex form, which is y equals a times the quantity x minus h squared plus k. The vertex is h comma k, and the vertical stretch shows up as the coefficient a. For this function, y equals 1/2 the vertical stretch times the quantity x minus the x-coordinate of the vertex 2 squared plus the y-coordinate of the vertex -3. So there's your vertex form. To go to standard form, using the order of operations, we need to start with x minus 2 squared. So essentially what we're going to do is multiply x minus 2 times x minus 2. One way to show this is using an area model. So the length of one side is x minus 2, and the length of the other side is also x minus 2. Then filling in the area model, x times x is x squared, -2 times x is -2x, again -2x, and then -2 times -2 is 4. Adding the 4 smaller areas, you get x squared minus 2x minus 2x plus 4, and then combining like terms, x squared minus 4x plus 4. Then you have to factor in the rest of the original vertex form, so you need to multiply by 1/2 and then add -3. The distributive property gives 1/2 x squared. 1/2 times -4 is -2x, and 1/2 times 4 is plus 2, plus -3. Then combining like terms, 1/2 x squared minus 2x, and 2 plus -3 is -1, or -1. And that is your standard form from vertex form. One last thing to observe is how the y-intercept shows up in standard form. You can see here the -1. If you go over to the graph, you can see that the y-intercept is at 0, -1. So we can see in standard form, the constant term, -1, is the y-intercept of the graph.